Let's have a look. Question 1. What are the oxidation states of chromium in these two compounds? We're looking at the first one. O is -2 times 7, that's -14. This here is the ammonium ion, which is +1, so in total it will be +2, which would make this chromium +6, since we're trying to get to 0, as this is a neutral compound. So either B or C. Then looking at the second one, again, O is -2 times 3 -6, which makes the chromium +3. So that will be B. Question 2. Which of the following is a redox reaction? Where anything that has an element will be a redox reaction. So that will also include diatomic molecules such as H2, Cl2, I2. But in this case, we see that we have this aluminium here. So that points us towards A. 3. What is the reaction type and major product at the anode when molten sodium chloride is electrolyzed using platinum electrodes? Okay, so since we're talking about the product at the anode, at the positive electrode, it will be the negative ion that goes there. So that will be the chloride ion. It will go to the anode, it will be oxidized, and therefore it will turn into the diatomic molecule chlorine. So either A or B. What's the reaction type? What happens at the anode? Oxidation. Oxidation always occurs at the anode. Keep that in mind. So that will be B. Number 4. What is the order of decreasing reactivity of the metals? So here the rule of thumb is most reactive ends up as an ion. Keep that in mind. Most reactive ends up as an ion. Okay, well, in the first one we have zinc and tin 2+, but it's the zinc that ends up as an ion, so that means that will be more reactive. So we're looking at order of decreasing reactivity. Okay, so zinc will be first, and it's more reactive than tin. We're not sure if anything comes between them. Second one, copper and zinc 2+, no reaction. So again, zinc remains the ion, which means it's also more reactive than copper. Tin and copper 2+, it's tin that remains as an ion. So the copper will go here. And lastly, silver and copper 2+, it's the copper that's more reactive. So the silver will go there. Which means our answer for 4 is D. Number 5. What is the oxidation half equation in the redox reaction? Okay, oxidation half equation. Looking at A, that's written as a reduction, so that's not an oxidation half equation. How do we know that? Well, here the iodine goes from being 0, having an oxidation state of 0, to 1 of -1. So that's a decrease in oxidation state, so that's reduction. Then in the second one, it's the other way around. Yeah, so that will be an oxidation half reaction, but that's not what actually happens in the equation above. It's A that we see displayed, which means it won't be A or B, it will be C. We don't even need to check the oxidation states here. We can see that there's an increase in oxygen. So it will be C. And obviously in D, there's a decrease in oxygen. So that will be a reduction. Number 6. Which statements are correct for a voltaic cell? A spontaneous redox chemical reaction produces electrical energy. Yeah. Oxidation occurs at the cathode. No, oxidation always occurs at the anode. Say it with me, oxidation always occurs at the anode. So that goes for any cell. Voltaic, electrolytic, oxidation occurs at the anode. And number 3, electrons flow from the anode to the cathode. Yes, that's true. So from the place of oxidation to the place of production. So that will be B. Number 7, which of the following does not react with dilute hydrochloric acid? Be careful, if that had been an S, then it would have been hydrogen chloride. So be careful with that. But here we're given an extract from the activity series, so we must be using that somehow. The rule here is anything below hydrogen won't react. Well, what's below hydrogen? Copper. And that's why 7 is B. Number 8, which element is reduced in the following decay? Well, we've actually already had a look at the first substance in the first question. So we know that O is -2. We know that this is +1. And this is +6. Okay. And then we know here that this is, again, -2. That doesn't change. This is +3. So already we see the reduction has occurred here with the chromium. So that will be 8C. Number 9, which of the following is not a redox reaction? Well, A is a redox reaction. There's a chlorine right there. So it won't be A. B also has elements. So does C. Which means it will be D. D isn't a redox reaction. So nothing's being reduced, nothing's being oxidized. 10. What occurs at the anode during the electrolysis of molten strontium bromide? Well, firstly, oxidation. Oxidation occurs at the anode, so it'll be A or C. It's the positive electrode in this case, so it will be the negative ion that goes towards it. So that will be the bromine, which means 10 is A. 11. Consider the following half equations. Which statement is correct for the reaction between potassium manganate and potassium iodide in acidic conditions? Because the manganate has a more positive standard electrode potential, it means it will be more of an oxidizing agent. So this here, more of an oxidizing agent relative to the iodine, which means it itself will be reduced. So then that means it can't be A. The manganate doesn't reduce, it oxidizes, which means it will be B, because the iodine must be doing that. So the iodide ion, rather, that is the reducing agent itself oxidized. The color doesn't change from brown to purple, it actually changes from purple to brown, because these are both written as reductions, but one of them has to be the oxidation. So then these will be switching places, and so would the colors. And D, well, that's not an oxidation because it goes from -2 times 4, -8, +7, 2 + 2, and that's a reduction. 12. What are the products where an 12. What are the products when an aqueous solution of copper 2 sulfate is electrolyzed using inert graphite electrodes? Okay. So here we have an aqueous solution. That means we're adding the ions that water breaks down into in this. So What are our positive ions? We have the H plus from the water and also the copper 2 plus, and that will be the cathode. Then at the anode, we have the OH minus, again from the water, and the sulfate SO4 2 minus. These will be at the anode. Now we have to pick which will be most preferentially discharged. The rule of thumb is, at the cathode, we want the less reactive. The less reactive out of these two will be the copper. Why do we want the copper? Well, because it's the less reactive, it will be most easily reduced. At the anode, the rule is that if there's a hydroxide competing with something like a sulfate, a salt, maybe a nitrate, then the hydroxyl will win. That will be most easily oxidized. The sulfate ion is too stable, and it's much more likely for a hydroxyl to come along, meet a hydrogen bond and form water. So just writing it down, the reaction that occurs at the anode is and that's from the data booklet. So that's where this oxygen comes from here. And we've established that it's the copper, so that will be 12C. Moving on to number 13, which change represents oxidation. Okay, well in A we can see that there's a decrease in oxygen. We're going from 4 here to 3, so it won't be A. In B we're increasing the number of hydrogens, so again it won't be B. In C we would have to look at the oxidation states. So N2O and NO. So here we have -2, which means the nitrogen will be +1, whereas here again we have the -2, but the nitrogen is +2. So yeah, that's oxidation. It will be C. In D again we can see that there's a decrease in oxygen, so it can't be D. 14. A reaction takes place when a rechargeable battery is used. Which statements are correct? Hydrogen ions are, well, which statements are correct? H plus is reduced. No, it isn't. The hydrogen is always +1. Apart from when it's in compounds such as peroxides. So it won't be I. The oxidation state of lead changes from 0 to +2. It's definitely 0 there. The sulfate ion is -2, which would make this +2. So that's correct. PbO2 is the oxidizing agent, so that would mean it is itself reduced. Well, this is -4, this is +4. If it goes from +4 to +2, it's definitely reduced. So that means it must be the oxidizing agent. So 2 and 3 is C. 15. Which statement is correct for the overall reaction in a voltaic cell? So because we can see that the nickel has displaced the silver, we know that nickel is more reactive than silver. Okay, nickel is more reactive than silver, which means the electrons can't be flowing from the silver to the nickel. It would have to be the other way around. Nickel is oxidized at the cathode. No, oxidation always occurs at the anode. The silver plus ion is reduced at the anode again. Well, that can't be right, which means it must be D. Silver has a more positive standard electrode potential value than nickel. Well, that would make silver more of an oxidizing agent, which is itself reduced, and that makes sense. Because what we'd have is, let that be silver and that nickel. The electrons are flowing that way, towards the silver, which means this must be the place of reduction, which is the cathode. So if the silver is getting reduced, that means it must be the oxidizing agent. Number 16, in the electrolysis of aqueous potassium nitrate using inert electrodes, 0.1 mole of gas was formed at the cathode. So which is correct? Gaseous product at the anode. Okay, so if we again quickly work out our ions at each electrode. We're seeing that there's a hydroxyl competing with a salt, which means the hydroxyl will win. This, as we've seen previously, will turn into oxygen, so it will be B or D. Question 16. In the electrolysis of aqueous potassium nitrate, using inert electrodes, 0.1 mole of a gas was formed at the cathode. Which is correct? So first, let's work out what gas was produced at the anode. So at the anode, we have the negative ions. Since it's an aqueous solution, there will be OH minus ions and NO3 minus ions. What are we going to pick? The hydroxide. Yes, that's right. We don't pick the salts. So what's going to happen to these hydroxides? What happens at the anode? That's right, oxidation. So they will be oxidized. Now, what's the electrode potential equation for a hydroxide molecule? We have OH minus going to half NO2 plus H2O plus 2 electrons. That doesn't quite add up because we have 2 O's here. 1, 2. We need 2 there. There we go. Okay. So what's the gas that we form? Oxygen. B or D. Now, how do we work out the amount of product at the anode? Having been told that at the cathode, it's 0.1 mole. So at the negative cathode, we have the positive ions. So those will be either K plus or H plus. Which one wins? The hydrogen ion, yes. The less reactive one. So what's the electrode potential equation for that? H plus plus an electron is reduced to half a hydrogen molecule. What we have to do in order to carry this question on, though, is balance the electrons, because otherwise we cannot compare the two equations. So if we balance the electrons, we get 2H plus, 2 electrons, and this turns into a 1. So looking at the anode, for every 2 electrons, what do we get? We get half a molecule of oxygen. 2 electrons, half a molecule. At the cathode, for every 2 electrons, again, we get a whole molecule of hydrogen. So if at the cathode we formed 0.1 mole, then here we will have formed 0.05. And that leaves us with B. Question 18. What is the standard half cell potential of copper? We're trying to work out copper. If the zero potential reference electrode is changed from the standard hydrogen electrode to a standard zinc electrode. So because the standard that we're changing to is more negative or is more reducing, we follow the usual protocol, which is 0.34 minus 0.76. These are going to add, and so we're going to get D. Now, had the standard that we're changing to, so had this one here been more positive, we would have actually got the opposite answer, which is A. So keep that in mind for other similar questions. Number 19. What are the relative volumes of gas given off at E and F during electrolysis of the two cells in series? So with copper sulfate, we're looking at the positive electrode, so that will be the anode. At the anode, we're going to have the negative ions. So here we're either going to have SO4, 2 minus, or OH minus from the water. Which one will be most easily oxidized? The hydroxyl, that's right, the hydroxyl. On the other side, with the sulfuric acid, we're looking at the positive ions, which will be reduced at the cathode. So we'll have the H plus from the sulfuric acid and the H plus from the water. So obviously we simply remain with a hydrogen ion. Nothing to pick from there. Then in terms of our ratios, we're going to need some equations. So for the hydrogen ion, we add an electron, we get half a hydrogen molecule. So let's just make that whole. We'll times by 2. So that will be 1. Then for the OH, 2 OHs. So we've just had that in the previous question. Half O2 plus H2O plus 2E minus. Looking at the ratio of gas, we have 1 molecule, half a molecule. This is F, this is E. The ratio is written as E to F. So 0.5 to 1, which will be the same as 1 to 2. So that will be B. Number 20, which compounds can be reduced? We have got an alkene, carboxylic acid, and an aldehyde. An alkene can be reduced to an alkane, so yes. Carboxylic acid can be reduced to a primary alcohol. Aldehyde, again, primary alcohol. So that will give us D. 21. Which experimental methods could be used to observe the progress of the following reaction? Change in color. Yes, we have iodine. Whenever there's iodine, you can measure a change in color. Change in mass? No solids. Change in electrical conductivity. We've got ions. So yes, we can measure that. 1 and 3 will be B. 22, which is a correct statement for the reaction below? So we're trying to work out reducing oxidizing agents just by looking at the loss or gain of oxygen. We can see that this substance loses its oxygen. So MnO4 is being reduced, which means it will be the oxidizing agent. So not the reducing agent. It is the oxidizing agent. It's self-reduced. That means its oxidation number decreases. So it will be B. 23. Applying IUPAC rules. What is the name of MnO2? Mn, be careful to not confuse it with magnesium, so it will be manganese. If O2 is minus 2 times 2, which is minus 4, it means this must be plus 4, so it will be manganese 4 oxide. 24. Which statement is correct for a voltaic cell but not an electrolytic cell? An electrolyte is required. Yes, it is. The anode is where oxidation occurs. Yes. Anode, oxidation always occurs at the anode. Ions move in the electrolyte. Yes, that's right. So then it must be the electrons flow from the negative electrode to the positive electrode. Yes, so that's where they try to catch you out. Because in an electrolytic cell, we have positive anode, negative cathode. In a voltaic cell, we have negative anode, positive cathode. A voltaic cell is constructed from zinc and copper half cells. Zinc is more reactive than copper. Which statement is correct when this cell produces electricity? So because zinc is more reactive than copper, the electrons will be flowing from the zinc towards the copper. If electrons are being lost at this electrode, what does that mean? What reaction is that? It's oxidation. Oxidation always occurs at the anode. That's right. So this will be the anode. That will be the cathode. So then electrons flow from the copper half cell to the zinc half cell. No, they do not. the concentration of copper 2 plus increases. No, it actually decreases. Electrons flow through the salt bridge. No, they don't. That will be the ions. The electrons flow through the external circuit or through the wire. Negative ions flow through the salt bridge from the copper half cell to the zinc half cell. Yes. So if the electrons are going one way, the ions will be flowing the opposite way. So they'll be coming back this way, from the copper to the zinc. Our answer is D. 26. Which are necessary conditions for the standard hydrogen electrode? To have an electrode potential of exactly 0. For this, generally, what we need is so 1 and 2, which will be A. Number 28. Which compound forms both hydrogen and oxygen at the electrodes when a concentrated aqueous solution is electrolyzed? Okay, so we're trying to get hydrogen and oxygen. Concentrated means that if we have any halogens, they will win over whatever they're competing with. So we can't have A or B, because I minus competing against OH minus, usually we'd say if there's no condition or if it is dilute, this will win, the hydroxyl will win. It'll be most easily discharged. But if it's concentrated, the halogen will win. The halide ion will win. So again, that knocks out A or B because we have the iodine and the chlorine. With C and D, let's have a look. What ions do we have for C? We have H plus from the sulfuric acid, H plus from the water, SO4, 2 minus from the sulfuric acid, and OH minus. So we'll have a hydrogen and the sulfate will be eliminated. So yes, that gives us hydrogen and oxygen. Let's just run through D to understand why that doesn't work out. We've got our ions, Ag plus, H plus, NO3 minus, and OH minus. So again, we eliminate the salt. Silver is less reactive than hydrogen, which means that's what we're picking. So then we would get silver from silver ions, not the hydrogen that we want. So that's where we eliminate D. Okay. Question 29. Which signs for both E cell and delta G result in a spontaneous redox reaction under standard conditions? So you've just got to learn that the E cell has to be positive and the delta G must be negative for a spontaneous reaction. 30. Z mole of copper is deposited from copper sulfate by a current in time. What is the amount of silver in mole deposited by electrolysis from silver nitrate by a current L divided by 2 in time 2t? Okay, right. Well, let's have a look at what it takes for a copper 2 plus ion to get to an atom and what it takes for a silver plus ion to get to a silver atom. So why is it a 2 plus copper ion? Well, I'm looking here. I'm seeing that there's a sulfate that's 2 minus from your list of polyatomic ions. So the copper must be 2 plus. We're going to then add 2 electrons, which will give us the copper atom. What about the silver? So that's silver plus, again, because the nitrate is minus 1, so the silver will be plus 1 electron, giving us a silver atom. So then if we were to pass through this circuit 10 electrons, how many copper atoms would we get and how many silver atoms would we get? We'd get 5 copper atoms, 10 silver atoms. So then we can see that if that's Z, this will be 2Z. So that will be D. Just a note of the equation that you might have not used here, but might come in handy in other questions of this nature. So that mole of electrons is the current times the time divided by the Faraday constant. In this particular question, we're not worried about the Faraday constant, so we're going to take that out. What they're trying to do with the 2's here, they're trying to confuse you. But what would happen is divided by 2 times 2. So then the 2's would just cancel out and you're left with the same current times time. Question 31. An iron rod is electroplated with silver. Which is the correct condition for this process? Well, let's say this is the iron rod, Fe. We're trying to electroplate it with silver here. So that means we're wanting the electrons to go this way. Well, that would make the silver the place of oxidation. And we know that oxidation always occurs at the anode. Because this is electrolysis, it will be a positive anode. So then, can we answer the question? The silver electrode is the positive electrode. Yes, it is. So electrons will always be moving from the anode to the cathode. The only difference is the charges of the anode and cathode in an electrolytic cell and in a voltaic cell. In an electrolytic cell, you have a positive anode and a negative cathode. You might have learned at GCSE panic, positive anode, negative cathode. With the voltaic, it will basically be reverse panic, negative anode, positive cathode. Question 32, which represents a redox reaction? Well, we know that we're looking for elements. I'm seeing an element there, so it'll be A. Straight away, you've got that in a paper 1 situation when you're trying to not lose time. You've spotted that element, that's it, there you go. 33, which species can oxidize ethanol to ethanoic acid? Well, that's more of a topic 10-20 question, but that will be the acidified potassium dichromate. 34, 2 half cells are connected via a salt bridge to make a voltaic cell. Which statement about this cell is correct? Oxidation occurs at the positive electrode, the cathode. Well, no, we know that oxidation always occurs at the anode, so it won't be A. It's also known as an electrolytic cell. Well, no, that's a different type of cell. Ions flow through the salt bridge. Yes, they do, and electrons flow in the external circuit. So that will be C. 35, what are the oxidation states of each element. Well, we know oxygen will be -2. Potassium will be +1. So that leaves us with A. If we are working it all out, the oxygen -2 times 4, that will be -8. The potassium +1 times 2, so that will be +2. It's a neutral compound, so we're trying to get to 0. So -8 + 2, -6. So then the chromium must be +6. 36. What is the coefficient for the iodide ion when the following equation is balanced, using the smallest possible whole numbers? Right, so looking at the iodine first, there's 2 on the left-hand side, 2 on the right, so that's fine. What about the oxygens? We've got 3 here, but only 1 there. So we're going to add a 3 in front of the water. That will give us 6 hydrogens here. So we want 6 hydrogens there. So we're going to add that in. Now that balances all the elements, and that would give us answer A. But what we would be forgetting is the charges. So the right-hand side is neutral, it's 0. So we want to balance that out on the left-hand side as well. We've got 6 pluses here, 1 minus from this, so that means this will be 5. These two will add up to be 6 minus, so that will cancel out the 6 plus, which will give us 0, which means the answer will be D. (37) A voltaic cell is made by connecting a copper half cell to an iron half cell. So which combination correctly identifies the positive electrode and the species being oxidized? Well, iron is more reactive than copper, which means the electrons will be flowing this way. If the electrons are leaving the iron electrode, this must be the place of oxidation, which we know always occurs at the anode. It's a voltaic cell, so it'll be negative ion. So the positive electrode must be the copper electrode. What species will be oxidized? Well, that would be the iron. The iron is the one losing electrons.